In this video, we're going to look at the particulate view of a voltaic or a galvanic cell. So remember that a voltaic cell uses a spontaneous chemical reaction to create electricity. So what we have here is we have a voltaic cell that has a zinc metal electrode with a zinc sulfate solution, and then we have a copper electrode with a copper 2 sulfate solution. So I have the two half reactions down here. Zinc is being oxidized to zinc 2 plus. Cu2 plus is being reduced to solid copper. And so I gave you these half reactions already, so we know that zinc is undergoing oxidation, copper is undergoing reduction. And the reason that we know that that is the case is because of what is called standard reduction potentials. In order to make this entire reaction spontaneous, copper 2 plus has to be the one that's being reduced, zinc has to be the one that is being oxidized. So if we take a look at what is happening during this process. So zinc, we know, is being oxidized. So we're going to take the 2 electrons that zinc loses, and we know that zinc will be oxidized. So what's going to happen is one of these solid zinc pieces from the electrode has 2 electrons. It is going to lose the 2 electrons. The electrons will actually move through the wire. So we already have some electrons up here, but the electrons will move through the wire. And what happens when zinc undergoes oxidation is zinc will turn into zinc 2 plus. So we're going to turn a solid zinc into Zn2 plus. Remember that ions are in solution. So now we have zinc 2 plus in solution. What's going to happen is the electrons are going to move through the wire down. So they move from the anode, which is where oxidation occurs. So this is the anode half cell. The electrons will move over into the cathode, which is where reduction takes place. So these 2 electrons are going to move down into the copper electrode. And what happens when these electrons are with the copper electrode is that Cu2 plus will come up to the copper electrode. It will gain these 2 electrons. And once Cu2 plus gains 2 electrons, it actually becomes solid copper. So what happens as Cu2 plus is being reduced to solid copper is we're going to notice that we're going to have more copper adding to the copper electrode. So the mass of the cathode is going to increase. If we look at this one more time, so we have 2 electrons that will be lost by the zinc electrode. So notice when the zinc loses the 2 electrons, zinc becomes Zn2 plus. So Zn2 plus will go into solution. The 2 electrons will move through the wire. This V just stands for voltmeter. So voltmeter is something that we can measure the voltage of this spontaneous reaction. And so the electrons will move through the wire. That's the only place the electrons move is through the wire. These 2 electrons will come back down into the copper electrode. This is where copper 2 plus, so the ion, will gain the 2 electrons that are flowing into the electrode. And when Cu2 plus gains 2 electrons, it becomes solid copper. So notice as this voltaic cell runs, the anode is reducing its mass. The cathode is gaining in mass. We have electrons that are flowing through the wire. Now if we notice down here in each of the half cells, let's take a look at the solutions themselves. In order for a voltaic cell to continue to run, the solutions in the half cells need to remain neutral. So if I notice down here, I see that I have a lot more plus than minus. I have 2 additional Zn2 plus compared to the sulfate, the SO4 2 minus. On the other side, in the reduction half cell, I notice that I have more negative charge than positive charge. In order to keep these electrically neutral, we have the salt bridge. The salt bridge is an electrolyte solution, typically potassium chloride like this, or sodium chloride, potassium nitrate, sodium nitrate, some sort of electrolyte solution. And what happens is we notice now the reduction half cell, the cathode side, is too negative. We need to add more positive. And so what's going to happen is we will have some of these K plus ions flowing into solution. So the cations will flow down into the same half cell as the cathode. And so what I would need is I would need more K plus in order to make it neutral. So in the salt bridge, we have this electrolyte solution that's essentially an unlimited amount of this electrolytic solution, K plus and Cl minus and ACl or anything like that. Then on the other side, we have too much positive. So the chloride ions from the salt bridge will flow down into the oxidation half cell. And again, we could add more Cl minus because this salt bridge is an unlimited amount of this electrolytic solution. So what happens as this runs is the salt bridge is going to work to keep these solutions neutral. If these solutions are not neutral, the voltaic cell will not run. So what happens is the electrons will flow from the anode to the cathode. So at the anode, we have oxidation taking place. The electrons will leave the anode. They will travel through the wire to the cathode. Cathode is where reduction takes place. And then to keep the solutions themselves neutral, as Zn is turning into Zn2+, and as Cu2+ is turning into Cu, to keep those neutral, we have K+ flowing toward the cathode. We have Cl- flowing toward the anode.